Okay. Your weekly warning that this lecture is being recorded. All right, what do we got to do? So last lecture, there's just some housekeeping that we need to go over, and I'm going to give you the opportunity to ask me some questions. So today we're just going to do this UqNO. I'll show you where it's at, and then we'll spend however much time we want programming it. If we finish early, we finish early. If we don't finish it, that's also okay. But today's going to be like a super informal class. I'm not really supposed to, well, I'm not supposed to teach anything new in the last week. So these weeks are either typically canceled or spent doing review, but doing UqNO is going to be review. Help during SWAT back. There is none officially. So the help center is closed after this week. It's the last week that it's open. So if you got a extension to A3, just keep that in mind. You're not going to get support next week. I'm out of budget effectively. Like, this is it. I get apportion some budget at the beginning of the year, and I try to spend it all on student resourcing, and I'm at the end of it. So sorry, I don't get allocated hours during SWAT fac. That being said, we're still going to monitor the EdStem. Like, I'm still paying my TAs for that, and I may sit in the help center because my office is across the hall. So, okay, I'm not going to sit in the help center, but if you come to the help center and go across the hall and I'm in my office, I'm happy to answer whatever questions you want. I'm happy for you to pull me out of my office into the help center if you have a group of students. I don't do the official SWAT back review day because every time I had done it and prepared, like, one person shows up. So this is not, one person in 1,000. That's not really a really good use of my time. But if you just email me, I'm happy to meet with any of you for help on the exam. Grade migration. Now, if you go to Blackboard, which is technically the official repository of your grades, it's empty, right? There's nothing there. Or is it there? If you go to your Blackboard and look for grades, is anything there? There shouldn't be. Okay, so here's what's going to happen. We're going to take all of the grades off of Gradescope, and we're going to put them onto Blackboard as soon as we evaluate A3. And then I'm going to send out an email saying, go check the Blackboard and confirm that your marks are correct. And you have 4 days to let me know that they're not. That is to say, I'm going to use the Blackboard as the master grading sheet. Right? So I'm going to do this migration. I'll send you an email. You check that the grades in your Blackboard are correct, and then I'll compute your grade from that. There's some things that we haven't applied yet in the Gradescope because there's no way. Like late penalties, we are unable. Like, you don't have a late penalty in Gradescope. We're going to apply that when we move to the Blackboard because it's kind of tricky to do that. CCATs, thank you if you filled out a CCAT. The response rates are still incredibly low, which is bad news for me because low response rates means that the people who hate me are going to have outsized effect on my score. So if you still haven't filled out a CCAT, it'd be a big help to me if you could. And if you could like tell your buddy or something to fill out a CCAT, that would really help my career move. So is there any questions about any of these 4 topics or about the exam? Well, I think I have a little bit more information on the exam. Okay, so if you're looking for help during SWAT week, it's either EdStem or you come find me. The exam. Anyone study Latin? This used to be something you would study at university. This is probably the best piece of advice ever given to me about writing exams. It's a Latin phrase called festina lente. Does anyone know what that means? It's a Latin phrase that literally translates to hurry slowly. Hurry slowly. This is to say that the faster you attempt your exam, the slower it's going to go. You're going to make mistakes. You have to hurry slowly. Right? So when you're going through this exam, don't try to rush it because you're going to make mistakes. This exam is effectively testing how detail-oriented you have become. Right? Some of the questions are deliberately tricky because debugging is tricky. Right? So I'll leave out an integer casting when I input something, right? So it inputs as a string, or I'll try to read from a file that we've opened for writing, stuff like that. So the code may be bad, and I'm testing your capacity of detecting it. So just keep that in mind. Obvious things that may not be obvious. If you can't answer a question immediately, skip it. Go back. You shouldn't be doing the exam like question 1, question 2, question. I certainly don't put any thought into the order of the questions. In fact, I usually randomly permute them after like I'm finished writing them. Okay, so there's not going to be any type of logic to the order. So if you can't immediately solve a question, just skip it and come back to it. You should be finishing your exam by making several passes over the exam. Okay, now suppose you can't figure out the answer to one question and you have like 10 minutes left in the exam. Do not spend that last 10 minutes trying to answer that one question. Guess. You have a 1 in 4 chance of guessing. So guess on the question that you can't solve and then use that 10 minutes to review your answers. I guarantee you're going to catch at least one mistake going through the previously answered questions. Right? So just try to use your time wisely, and some of that time should be allocated for double checking your answers. Okay. I am not allowed in the exam room. So I'm not there because I can't, so like I would really like to be in the exam room with you. When I was at U of T, I would be there and I would hold signs of supports and be around for you guys. I would literally hold signs just saying, just do your best and you can do it, which you can. But here, there's a policy which says I'm not allowed to be, I don't know, in the exam room. So don't interpret my lack of being there as a lack of support. What I'll be doing, like literally, is sitting at my desk, staring at my phone, right? Because I will, have you guys have taken exams already? Are you familiar with the policy of asking a clarification question? So if you find like a mistake on my exam, which is highly likely, right? Because I've written like 40 questions, and if a semicolon's out of place, it totally changes the meaning of the question. You have to raise your hand, and a proctor comes to you with a piece of paper, which you write down your concern. Then they take that piece of paper and then they call me and then they read out that concern and then I speak back to them. They write down my response and then hand that paper back to you. It's an exceedingly efficient system that I can't speak better of. But that's the case. There's going to be clarification. I've never run an exam here where some announcement hasn't have to have been made. So just expect that there may be 1 or 2 things off. That being said, if I screw up a question, I'll just accept multiple answers. If not, just accept all answers to a question. So if you see a question which you think there are multiple correct answers, maybe I screwed up and there are multiple correct answers. And if that is the case, I will accept all of them. So and even if I write a question where I didn't make a mistake and like 1/3 of the class answers A, then I'll still accept A. I'm like, well, then this was my mistake. Like, I clearly have asked this question wrong or like asked it in a confusing manner. So there is some democratic scoring in this case. So, but don't try and collude, like just get the whole class to respond to A on each question. Okay, so keep that in mind. The last thing is that your exam is slightly different than most of the previous exams in this class. Last term, we changed the exam a little bit because every year I get complaints that, and it's a valid complaint, that what we have taught you to do is write code. And then on the exam, all you do is read code. You don't write any code on the exam. So in order to address this, there is now a full solution question on the exam. There is an opportunity for you to actually write Python code. So it's a 5-mark question. It's the last question on the exam. So that's the one full solution. There's 30 multiple choice questions that are very similar to previous exam questions. There's 5 fill in the blank, but it's not really fill in the blank. Every exam, there's a question about object inheritance. Like if you've seen any of the exams, there's a question with class A, class B, class C, class D. There's always around 5 questions to do with that inheritance composition. So instead of having multiple choice for that, like the answer is always a number. So instead of having multiple choice, it's just a box where you write the number, because I'm trying to test if we can move the whole exam from multiple choice to optical character recognition. So the 5 fill in the blank isn't really fill in the blank. It's multiple choice, but you have to write your number. I'm just doing it to prevent guessing. So is there any questions regarding that? Okay. If you have a whoopsie on the exam and you fail it, you may get allocated a mark of 3, which means that you may have another opportunity to write the exam. So keep that in mind if you're traveling home, that if you travel home and you failed the exam and you need to write the supplementary, that supplementary has to be written here. And it is university policy that we say we expect all students to be available to sit exams during the supplementary exam period. Now, I know I may be telling you this too late. Sorry, but just keep that in mind. If you travel home, find out you failed this exam, there are no external exam options anymore. We do not offer that. So it is technically policy that we expect you to be here for a written exam. I also, if you get a 3 in this course and you did pretty well on the exam, but maybe like you didn't submit A2, then for those people, there's another assignment that I just give. Like I give another, you have to do A3 over again, a different A3, and then you'll pass the course. But let's hope none of us fall into that category. I just remind you that there is an exam hurdle, right? You got to get 40% on the exam minimum to pass the course. And then please don't be angry at me after I compute grades. Some of you will fall at the boundary, and it's going to hurt to be like, I could have had a full grade higher if I answered one more question on the exam correct. And it's like, yeah, that sucks. But like, I have to set the boundary somewhere, and no matter where I set them, people are going to fall on it. Yeah, so I usually, when calculating the grades, am very generous. Every calculation I do, I round up, every single calculation. So I'm giving everyone the best chance to make it across thresholds, and I'll probably reduce the boundaries too, depending how everyone does. Okay, so any questions regarding like grade migration or the SWOT back or the exam period or anything else to do with this course, or should we just start doing programming the card game now? Or should we just cancel the lecture and enjoy the nice day? Okay, UqNO. Let's do UqNO. So I'll show you what I programmed as promised. And then we'll try to do as much of it as we can today. Okay. Who wants to play? There we go. There's my UqNO. The green field here represents the active player. The blue field represents the next player. You can draw a card, but you can't pass yet. In order to pass, you have to draw at least once. That's the discard, and this is the deck. I had to change the game. At first, I was going to design it so that it's only human players, but then I realized that you can't make a multiplayer card game on the same screen. Does anyone know why? You get to see everyone else's cards. It kind of defeats the purpose of the card game. So I swapped it out. I changed it so that it's 1 human player versus 3 computer players. But, okay, so let's play this a bit. Are we familiar with the rules of UNO? You either have to match color, or you have to match number, or you have to play some special cards. So I do... Okay, so I can click cards like this. If I double click them, it rejects it if you can't play it. This card I am actually allowed to play. So let's click this. This card is a wild card, which obligates us to change its color. So this is something we're going to have to think about. So if I click this and click again, I get this window that now asks me for which color that I want. So what color should we choose? Yeah. Red? Okay, so it may happen fast, but I'm going to hit red, and then the card that I just played is going to be red. Because that's the other thing, right? That's kind of confusing when you start implementing these things. So the rule says play a card, and then say out loud what color it is. It's like, well, you can't really do that I can't play this black card and be red. to the computer. Like everyone has to know that it's red. So it changes to red. I don't know if you saw that briefly, but that black card changed to red. And when we're going to have to unred it. That's the other thing that's going to be complicated. We have to revert cards back to being colorless. Okay, so it's now back to me. There's a 5. Maybe I play. Okay, this one is skip a turn. So we should see that this player that doesn't get to play, it goes to here. Yep. Okay. Green. I can't play green, so I draw. And once I hit draw, I can't draw again. So now that button is deactivated, but I do have the opportunity to pass. That's why that button became activated. Can I play? No, so I pass. Oh, threes I have. Ah, okay, so that card is pickup 4. And I believe, you see here, that's the pickup 4 card. It's black, it's colorless. But I designed this in such a way that when the computer says I'm playing this and it's yellow, the card actually becomes yellow, right? So I can see it and and the game logic still makes sense. There's like one rule of UqNO, or UqNO, sorry, not UNO, Mattel. Don't come after me. This is totally different. When you get down to one card, the rule of UNO is that you have to scream out UNO, and you have to be the first person to say UNO. I can't program that. That's just something that I don't think I can get into the system. Okay, let's a few more rounds, but I can't beat the computer, like, which is really sad because it's just playing randomly. Can I play anything? No. Draw. Pass. Okay, maybe it's enough of that. But it's actually one of the computers is going to win. Let's just see if we can't trigger the condition. Okay, so we got to watch this person. We lost. So winner. So I didn't really program a dialog box saying, do you want to play again or not? That's all stuff that we can do. So if we look at this viewer, which is, the most of the meat of this code, I hope you have enough tkinter to start seeing, like, what are the components here? Like, I hope you can see, oh, there's obviously a frame up here, and then a middle frame, and then a bottom frame. And the bottom frame is broken up into a canvas and 2 buttons. And the middle frame is a canvas, and this top frame is 3 of these enemy fields. Right, so that's how I designed it. There's like the human playing field, the table top, and then the enemy field. And the enemy field is broken into 3 mini fields. So we'll come back to this. This is like the objective. But there's a lot of work that we have to do to get here. Like, for one, there are no art assets. This is all 100% drawn by tkinter, right? So like this is drawn by tkinter. The shadow I simulated with tkinter, right? This is an old design trick back in the early noughties. If you write some text and then you write the exact same text underneath it, but black, and then just shift it down and across, then it looks like a shadow. That's all I did for here. So in fact, I have a routine that says, give me a color and a symbol, and I'm going to draw you a card. Right. So all of this stuff was drawn programmatically. Its footprint is very small, right? Pictures are big, instructions are tiny, right? So the thing that I'm proud about this is that I didn't use art assets. It's pure Python code. Okay, so let's close that. And let's look at what we were doing, like how far we've come. So we have this UNO class. We have this class UNO, which is to say that this is the UNO that I'm developing with the class. Inside it, we have a class for a card. Cards can have colors and values, and they can be special or not special. We decided on some type of unique 3-character representation. And we built some type of viewer that's just going to print all the stuff to the screen. So maybe I can just run this. Okay. So I think that's what we did last class. Here's the viewer. So the viewer is showing your hand, right? So this is something like blue 9. These are the opponent's hands, and it's saying the active player is 0. The direction of play is 1, that is forward. And we're showing blue reverse. That's what's that means. It probably should say next player too. So let's see. Okay, so the viewer takes hands, active player, direction of play, showing. Okay, let's put more stuff into this renderer. So what the model has done. So it's just I've spun up the model, I've spun up the viewer. The model can't do anything yet. The only thing the model is capable of doing at the moment is like setting up the deck and dealing cards. That's all it's done so far. So after we've set up the deck and dealt the cards, I want to be able to view the state of the game. And that's what the viewer is doing, which is the thing here. But I want to add one more piece of information here, and that's the next player. Next player. That's going to be an integer. What else do we need to know? So we need to know what the hands that everyone else is holding, who the active player is, who the next player is, what the direction of play is, and what card is showing. Is that going to be enough? Okay, let's say that's enough. So I just have to give active player is that. Let me say next player is next player. Direction of play is that. Showing is that. Okay. So this one just, and now I need to, in view, just give it m dot next play. And we're being really cheeky here. I'm accessing private variables that I'm not supposed to, but we can address it. Like eventually when I'm settled on what my view interface is going to be, right? Then I can write the getters that, I can write only the getters that I require. Okay, so let's try this. Okay, so this is good, right? So I have a model and I have a viewer, and that viewer can, this is a render of the model. Right? It's giving us the exact same information that full TK-inter1 was given, but it's much easier to program. So every time I say view.render, it's going to show me the state of the model. Right? I can see what the model is holding. Okay, so what's next? We need to be able to play a card. So how does that work? What do we have? We have an initializer. We can shuffle the deck. We know what's showing. We can draw a card, which should be a mutation, actually. So what I mean by mutation is something that's actually changing the internal state of the model object. It's been mutated. It's different. So that's how I'm organizing these methods. So I can shuffle the deck. That's a mutation. I can draw from the deck. That's a mutation. And I want to be able to do something like apply. What did I call it? Apply. Yeah, just apply. Okay, so how are we going to do this? So the model is responsible for enforcing all game rules, and that is to say the model has to be the what contains Python code that is instructing the model, like what it means to +2. So if I want to apply something, I need to know what the card is. So this is going to be type card, and I need something else, but we'll discover it. Okay, so what is this going to do? Apply the effects of playing card. Okay. So what should we do here? So I'm going to say that, hey, model, play this card. What does that mean? How should we handle this? Pardon me? Count the number of cards in my hand. Yeah, I want to use one card, and I'm telling you it's this card. So I'm going to hand you an UqNO card. You're the model. I'm saying, apply this. So let's all recall what the model's supposed to do, right? The model is responsible for state changes. So when I say I've played +2, the model is the thing responsible for saying, okay, your hand loses that card. It gets put into the discard. And then the next player has to pick up 2 cards and, in fact, also miss their turn, which is a rule I never knew about until I bought UqNO. Okay, so let's see. If I'm saying I want to play, and let's have a precondition here. The card is legally playable, right? So we don't have to check that if you can play it. What kind of cards are there? So we have well, more generically, we have numbered colored cards and then cards with special actions. Okay, so suppose it's not a special card. If not card is special, which I believe, probably should write that. So this is this wish list programming, right? I'm just using the interface and then designing it later. So I'll do something like here is special, self, return is special. Okay. And then down, we can forget about the viewer for now. So in this model, if card not is special, right, then it's just, it doesn't do anything. So all we have to do is put that card into the discard deck. Yeah. So we just say self dot discard is appended that card. Okay, nothing happens. So I put it on the table. Okay. But now, and then we can return. We're done. Here, card is special. So now what do we need to do? Well, what kind of special cards are there? Let's focus on the colored ones. So there's one that says skip turn. There's one that's switch the direction of play and pick up 2 cards. So let's focus on this one, skip a turn. So I want to say something like if card is skip, right? Then we want to, well, we always have to, actually, let's not add this to the discard deck. Let's let something else do that. We'll just apply it. So if the card isn't special, there's nothing to do. If the card is a skip, right? The card that you've played is a skip. What should we do? Well, this means next player misses turn. So how do we make the next player miss their turn? Okay, so let's remember what the model knows. So these are all the things that we've told the model to remember. Is one of the things next player? Okay, so that's what we have to change. So how do I make the next player miss their turn? That's 80% correct. What if I'm player 3? So there's players 0, 1, 2, and 3. So you're saying add 1 to it. Well, the next player is 4, but there is no player 4. So you just need to add something. So what should we add? You want to go from 3 to who? Who's the next player after 3? Yeah. Yeah, we use a mod, right? So it's the active player plus 1 mod the number of players. Okay, but that's still not the complete story. What if you, when my colleague over there said +1, what if we assumed? The direction of play is clockwise, but the direction of play can be anti-clockwise. So we need to know, so we're either going to add 1 or subtract 1, and then do mod the number of players, and we should be sorted. So am I remembering the direction of play? I am, actually. And what did I say it was going to be? Well, either +1 or -1. And why did I choose +1 and -1? because that's what I'm always either going to want to add +1 or -1. I don't care. It's just stored in that variable now. Okay, so if card is skip, then the next self dot next player is equal to self dot active player plus self dot direction of play. All of that has to be taken mod number of players, which is a constant that's defined in a constant file, but the number of players is 4. Right, so if you're at 3 and you want to increment by 1, that's 4. Mod 4 is 0. So we've gone from player 3 to player 0. If we're at 0 and the direction of play is counterclockwise or anti-clockwise, since we're in Australia, you would do 0 minus 1, which is -1. Mod 4, 3. Right, so you see this works. Okay, so if the card is a skip, we've managed to skip. And then I want to just return, right? We're just going to say we're done. Okay, we've done skipping. What about this one? What does this card do? Reverse. So how do we reverse? If card is, and I have to, these methods don't exist yet, but we'll go right. Okay, so if the card is a reverse, what do I do? I have to reverse the direction of play, but the logic that we have for the direction of play is that it's either plus or -1. So how do I reverse the, I don't want to say polarity. What is it? Reverse, is it signature? There's some word in math that designates something as either being positive or negative. Parity. Yeah, we need to reverse the parity of that number. So if positive, make it minus, and if minus, make it positive. Isn't that just negation? If we're +1, I want to make it -1. And if I'm -1, I want to make it. So I just multiply by -1. That were okay. Because we were clever about how we encoded the direction of play. Right. Okay, so self dot direction of play times equal -1. Boom. That's it. Okay. The only reason this is easy is because we've made clever design decisions in the past. Don't forget that I tried to, the model I had a little bit of difficulty setting up. So I had to change some design decisions, but yeah, this was really working. Okay, so what we have skip, we have reverse, we have +2. Okay. If card is, I can't use symbols. +2, I guess. Whoop, dot is +2. Okay, so the rules of UqNO say this about pickup 2. The next player picks up 2 and misses their turn. I had no idea that I've been playing UqNO wrong my entire life. Okay, so we have to do 2 things here. Next player picks up 2. And then next player misses turn. Okay, we have misses turn already. So I'm just going to put that here. I've done code duplication and it pains me, but I don't think there's any way around this one. Yeah. Pardon me? I don't, is skip is answering. We'd have to call apply. And I'd have to, and the way apply is working, it says, give me a card. So I'd have to say, oh, if this is a +2, make the player pick up 2 and then apply skip. And it's we're breaking the model is supposed to be like a real world representative of the thing we're modeling. And that's not how UqNO is played. You don't play the skip, the +2 card and then are handed a skip card. So I'm okay with duplicating one line of code, though I acknowledge that it's painful to do so. Okay, so next player misses turn. That's finished. How can we make the next player pick up 2? Yeah, we force that player to draw. Or we call the draw method here, right? So the model is able to draw things from the deck. So I need to say something like, Okay, self dot the okay, hold on. What methods do we have right now? Okay, so all of the hands are in the hands. So I need to look at self dot hands. I want to look at self dot active play. No, sorry. Next player's hand. And to this, I want to append self dot draw. Okay, that's the next player drawing one. Whoops, that's in the wrong place. That's the next player drawing one. That's the next player drawing again. Right? So the reason I have to do this twice is because every time you draw from the draw pile, that draw pile may be empty. Right? So if it's empty and you try to draw, the draw method knows that it should move the discard pile into the draw pile. I'll just remind you of that. But that's why I really have to say next player, draw something. Next player, draw something. And I know I also repeated here, but that repetition makes sense because you're drawing twice, right? So 149 draw, line 150 draw. Okay, so those ones aren't bad. But now we have to move to the special cards. Or no, the colorless cards. Okay, so these ones. So what did we, okay, so something like if card is wild, then what do we do? Okay, so here well, what does it mean when the card is wild? So I play this card here. So it means that I get to choose the color. Pardon me? I'm in the model, though. Model's not allowed to ask for player input. Who's responsible for player input? No. What's the thing that's interfacing with the user? Well, if it's not the model and it's not the controller, it's the viewer, right? The controller is the conduit between the model and the viewer. It's the one that sets up all of the communications between those two classes. Okay, so here I want to do something like the card dot change color. Yeah, I need to change the color of that card. Right, I showed you already. This is how my game works. When I have a colorless card, the game asks you what color you want it to be, and then that card becomes that color. Right. So when I play it on the table, all the game model still works. So I need a color here. Right, something like get color. How do I do that? I use a callback. You've seen these in what you're doing right now. I don't know why it's not letting me use callable as a type hint. Often upgraded, maybe. From typing import. Oh, okay, sure. Okay. So what this callable is going to be, or this callback function, it's going to accept nothing. It takes no input, and it returns to you a string with string in card.colors. All right, so I'm just going to hand it a function, right? So the only thing that we assume is that this callback, when I call it, is going to be red, yellow, blue. Is that true? Is blue one of the colors? Yeah. Red, yellow, blue, green. Okay, so all this, I'm in the model, and all apply knows is that it has access to a function that when it calls it, it's going to get a color, random color. And that random color is chosen by the human, but at this level of abstraction, we're not even aware there is a viewer, right? So the way that we have to conceptualize this is like, I have a function, and if I need it, I can call it. And when I call it, I'll get a color. That's all we have to. And then it's not going to be hard to hand this a function that does it. And I'll show you once we finish this. Okay, so if card is wild, we just want to change the color of the card to that and then return. And if card is pickup 4, notice that pickup 4 is also colorless. So we have to do the same thing, ask to change its color. And then we have to have the player pick up 4. So rather than, well, I can do this. Yeah, let's leave it like that. Instead of pasting this 4 times, we can multiply. Multiplying is a scalar operation. To multiply something is just to, like, we can't multiply an action. Like, what does it mean to 3 times print hello world? Well, I know, like, conceptually, okay, so you're saying, why can't we repeat this? So let me ask you this. What control structure do we have that repeats something? Loops. So if we don't want to do it like this, I can just say for some anonymous counting variable in range 4. Works for me as well. So either I would have accepted, right? Because this way is certainly less lines and better for that reason. But when I'm working in this model, I'm thinking, create a real world analog to the game. And in a game, I would say draw, 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 right? But it's exactly equivalent, logically equivalent. It just comes down to preference. So I'll leave it like this. Okay, so we've changed the color and we get a callback. So it's actually the case that these returns aren't needed because it can only trigger one of the cases. Let me pull up my master rule set. I even brought it. Shit. Okay, I don't have my scroll. Well, if it does, I just add one more line of code. I don't think it's also skip. But again, if it was, I could add it. Okay. And remember, this is UqNO, so it's our slight variation from the Mattel branch. Yeah. Pardon me? Yes. If there's 2 players, it's players 0 and 1. Then it goes 0 plus 1, mod 2 is 1. If the active player is 0, the next player should be 1, right? If it skips, did we do skip wrong? Yes, thank you. That's a bug, people. I'm not adding 1 to the active player. That I have to add 1 to the next player, right? Yes, good job. A+. I can give as many A pluses as I want because that's not a grade here, right? If I gave you a 7, that would be different, right? But A pluses to all of you, and S's to those of you from Asia, I guess, right? I have an Asian mom from the Philippines. A plus isn't good enough, so we had to invent a better grade so I could get that, and that's an S. Okay, so that seems to have corrected it, because if I'm player 0 and the next player is 1, if I add 1 to that, you get 2, mod 2 is 0, right? So now we've skipped. But like 2-player UqNO is kind of a degenerate case because all of the rules change to accommodate for the fact that you're, yeah. So let's just assume we're playing with 4, but that was a bug. And okay, what does chat have to say? Same thing in P2. Oh God, thank you. See, this is exactly why I don't like code duplication, because I changed it here, but I forgot that I have to also change it somewhere else because I have 2 lines doing the exact same thing, and it was broken, right? So if instead I had here something like, maybe see, now I should have learned my lesson. Nah, I haven't learned my lesson because I'm lazy. Okay, this. Okay, I think that should solve it. Okay, so have we done all of the cards, types of cards? So non-special cards sorted. Skip, we've sorted that. Reverse is sorted. Next player picks up 2 and skips is sorted. I'll just add that. Here, change card, that's fine. Yeah, change color, and next player picks up 4. Okay. This isn't going to work because we don't have any of these methods that I just used. So let's just make them. So let's just try to remember. Oh, I'll split the screen. Okay, so these are the things that I need to implement. So let's just go up to my card. So here's my card. So I just have to add those. Oh, I do have an is special. Oh, I think I just wrote that. Def is skip. I need. So this is going to return a bool. This is going to return a bool. Let's just pass. Def is reverse. That's going to be a bool. Let's pass. Def is pickup 2. That's going to be a bool. Let's pass. Def is wild self. That's a bool. Pass. Def card is P4. Bool. Pass. Okay, so how do we determine, oh, self is skip. So how do we know if this card is skip? Well, we have these attributes that it's holding. Let's get rid of this. We have these attributes. So if it's skip, its action should be skip. And its action is stored in its value. Okay, so here I need to say something like return self.value is equal to, what did we designate it as? Skip. Return self.value is reverse. Return self.value, pick up 2 plus 2 is wild. Wild was wild. And pick up 4, I believe, was pick up 4. Whoops. Okay, so now we have all of those convenience functions defined. So let's see if we have any syntax errors. No, we're still good. Okay. Here's a problem. So here, when we applied a card that changes color, do we have change color defined? No. Okay, so we also have to have a mutation in card. Mutation def change color self, and you need to give me a color, which is a string, and I'm gonna do nothing with that. Okay. Let's be smart. I can say if the color that you've handed me is not in cards.color, colors are not in self dot colors. This what kind of error should I raise here? Why is this complaining? Strike card. Anyone know why I'm getting a syntax error here? Oh, yes. I don't know why I put this there. Okay. So what kind of error is appropriate to raise here? So this is a precondition. So we've assumed that color is already the right type. And I'll have to check that if it's an integer or something. Okay, so by line 45, I know that color is a string, but I need it to be a particular type of string, right? Either red, yellow, blue, or green. Value error. It's the right type, but it's not the right value. And I can't, if you pass this chartreuse, I can't do that action. So here, I'm just going to raise a value error, which is for us, basically. This will help prevent us from making mistakes. So otherwise, we want to do something like self.color is equal to this new color. Okay, so that changes the color of the card. Okay, but what does this mean? All right, so I play a wild card. I say it's red. It gets played, and then eventually it gets shuffled back into the deck. Is that okay? Why not? Because the next time you see that card, it's going to be red. So how do I fix that? I'm going to do this. I'm going to say I have a heal method that reverts colorless cards back to colorless. Okay, so what's true? If self is, which ones change the color? Yeah, is wild, or self is +4. Okay, those are the two cards that could have changed color. Okay, so if it's either of these, to heal means to take self and change color back to none. Oh, and I should add that here. If color not in card colors or not color, right? Because it can also be none. Okay, so now I can heal a card. And there's a method to say, hey, if you used to be colorless and now you have color, go back. But what should I do with this? Yeah. We have in the model an instruction here in draw that says if you've drawn the last card, you have to move everything back from the discard deck back into the draw pile and shuffle it. So here, instead of moving to the discard deck by making this copy, I'm going to do this. Okay. Map, remember this? Heal. Here's the things here's the list I want to move. To every member of this list, I want to heal that member of the list. And this is precisely what a map does. Wait, I can't do it this way. I have to use a list comprehension. Card.heal for card in there. Okay, so I'm saying, get me the discard. And for every card in it, heal it. No, that's not going to work either. I'm not programming very smart today. here's the deck. Okay, because let's look at what I did here for healing. What does heal return anything? No, it's an instruction to the card to change itself. So I can't put that in a list comprehension because I would have gotten none back. So what I'm just going to do here is just say for card in self.deck, just card.heal. Okay, so once I like made the new deck, I'm just going to go through all the cards and say revert back to your initial color if necessary. Okay, move to discard deck. Revert special cards back to colorless. Okay, all right, so you can see all of this is automated, right? And since we like have actions that we're performing, we can always go into those actions and do things like setting up these filters, right? So the fact that we've written way more code than necessary to generate what I have done, the modularity is now beginning to benefit us, right? Because we know exactly where we need to go in our object to make some type of intervention. Okay, so I can create cards, I can shuffle and distribute them, and now I can apply them. Okay, so I want to now test our applications to see if they're working at all. So let's just try and hack away a bit here. Okay, so I'm gonna go. Let's go into this class UqNO. Okay, so I currently have a model and a viewer. So what I want to do now is sort of try and apply some of these cards. Or I can even say, okay, so if I'm player 0, the next player is 1. So what happens if I take this model and I apply, m.apply. Okay. And I'm just gonna create the card. I want, is it color action or action color? Color action. Okay, so let's say this card is red +2. And I have to give it a callback function. So I'll just, here, that's a function. It's trivial. Just if the identity function doesn't do anything. Or better yet, here's a function that when you call it just returns the color red. Right? Red. Okay, so what should we expect to happen? Active player is 0. I'm saying that active player gets to play a card that is +2. So, and then I'm going to print out the state of the model again. But what do we expect has happened? Right? I don't ever hit enter before you have an expectation of like what the correct answer is. Right, so this is me, that's the active player. So if I hit enter here, I expect this player to get 2 new cards, for the current active player to be 2, and the next active player to be 3. If we implemented this correctly, all of that should happen basically automatically. Oh, and it will be showing red +2, yes. So technically I'm not supposed to play this card, it's not legal. It's not playable, but there's nothing in the model yet that would prohibit that. So we'll handle it. But nonetheless, this should apply as, yeah, doesn't care. It just assumes that the card is playable. So hopefully this is going to work. Okay, so I applied it. I hit it. Why didn't we see anything? Well, I didn't instruct the thing to show anything. But what has happened is that the internal state of our model has changed, right? One thing is played. So hopefully, if I now say to my viewer, to render the, do I have to give it, oh damn it, okay, I'll just do it like this. Okay, if I render the play field now, didn't work. Okay, what didn't work? So this player didn't get 2 more cards. The active player didn't move, the next player didn't move. So what did we do anything? Well, now we have to do some debugging. Let's see. Could anyone see why that didn't work? Okay, so let's go find our +2. And I'll just say, we get here, just to see if we get there. Whoops. Let's see. Okay, something is wrong because we certainly should have got into there. Okay, so let's do some debugging. So if I have this, that's the card. Is the card, this should be a pass 2. Yeah. So what isn't happening? Okay. Print. Hello. Hold on. Is this card special? No. Okay, so if not special. Oh, I have the wrong interpretation of special. All right, so I don't think I actually need this. Because if the card is just a normal numbered card, then it won't be this and won't be this and won't be this and won't be that and won't be that. And nothing really needs to be done. Okay, so I'm going to take that out and see if that corrects things. Let's try to apply that. Yep, okay, that's good. We got here now, which is not where we didn't get there last time. And let's take a look at the viewer. Aha, okay, so player 1 now has 2 extra cards. Active player is wrong and next player is wrong. No, next player is correct, right? Because the next player was supposed to be, okay, what? We expected next player to be 3, right? Anyone? Okay, because I'm active player, which is 0. I play a +2, so that means player 1 should have 2 more cards. The next player should be 2. Oh, yeah. That's correct. Yeah. Not until it's the next turn. Right? I've played my card. I am still the active player. The next player has changed. But now, okay, so let's just do that now. Mutations. Next turn. So what does this mean? The active player is now the next player. The next player is self dot next player plus the direction of play. All of that mod the number of players. Okay, so let's try there. I'm going to go out, back in. I'm going to apply that card. I'm going to render. It's okay. I'm going to tell the model to do the next turn. I'm going to render that. Active player is 2. Next player is 3. Sorted. Yeah. Pardon me? Oh, yeah. Why is it showing that? I never actually, well, I didn't, in my apply, I never moved it to the discard deck. Well, yeah, because I want to say something like draw the card, apply it, and then put it on in the discard pile. Like we could put that in apply, but like I want to keep, yeah, these separate actions separate. Because we may have to intervene at some part of this chain in case. Okay, so we can do, okay, so next turn does that. So let's start building what is effectively one iteration of the main game loop then. Okay, so it's going to be something like active player play. Okay, so what should we do when an active player plays? What are the steps here? What does one turn of UqNO look like? Yeah, play a card if you, and it's not if you can, it's if you want. Yes. And if you and if not, and then exit. Or draw, and then play a card if you want, and then pass. So this is the rules of UNO. Okay, when it's your turn, you have two options. You can play a card from your hand if you have one, or you can draw. And there's no rule that's saying you can only draw if you don't have a playable card. Draw is always an option when it's your turn. So play a card if you want, then draw. Once you draw, you're not allowed to draw again. And once you draw, you're allowed to pass. So you can see how this sort of gets tricky now when we have to like incorporate this into computer code, right? So we play a card if we want. Okay, so this means that we have to be very careful here. So let's think practically speaking, how are we going to do this? So now we have to imagine this model needs to be instructed to do things. It can't make decisions. It needs to rely on the viewer for that. But it's okay. We can write callbacks to the viewer that do anything that we want. So what is one thing that we're going to need to do in here? What does it mean to play a card if you want? Programmatically. Pardon me? Remove what card from the current list? That's what I'm looking for, right? We make a call back to the viewer for what? To say, ask the player if they want to play a card, or get a card from the player, the one that they want to play. I'll make a little change to this. I'm going to allow the player to say nothing, right? So I'm either, okay, so let's write a callback here. And the callback is going to be a function that takes nothing. And, oh, sorry, that takes a list of cards and gives you back a card or nothing. Right, so I'm going to say, here's a hand. Viewer, take this and select one of the cards. I don't care how. The viewer's like, I know, I'm going to ask a human which card that they want to play. But I'm also going to let the human sort of say nothing, right? So that is what we're going to interpret as I would like to draw, right? If I don't select a card, I am passing, okay? So play a card if you want. So it's going to be something like if callback, I have to give it self dot hands of self dot active player, or active player. Okay, so I'm saying call back. Here's the hand of the active player. I want you to choose one of them for me. But we have to be okay. So when I showed you my tkinter version of this, I said, oh, my viewer is actually preventing me from selecting cards that are not playable. Okay, but the viewer has no idea what cards are playable or not playable. The viewer has no idea we're even playing a game. So here, what I also want to do, I want to give this two things. I want to say, I want you to select from these cards, but only this subset of the cards are actually playable, right? But you still have to render them all, right? I'm still showing the player all cards, even though only some of them can be played, right? So I'm gonna pass two arguments here: the hand, because you're gonna have to draw it, and then a list of cards that the human player is allowed to pick. Okay, so we're gonna have to figure that out too. So I'll do something like this. This is the current hand. And this is playable. And we're going to have to like figure out how to do that. We're going to say call back with this hand and this playable. And I call this a card. Playable. Oh, this playable. Okay, so get a card. Okay. If not card, then we have to draw and do it again. So how do we draw itself? Well, it's this. Dot append self dot draw. And then we have to do the whole thing again. Okay. So you pick a card and you can answer no once. And then I give you a second chance at picking a card once you've drawn a card. And then at this point, I apply it. So how do I apply the card? Well, that's easy. Apply it. Self dot apply that card. Okay. So I'm saying in the model, I have a method, and that method is the rule or the set of instructions to have one player play one round of UqNO. And how does that look like? Well, pick a card from your hand that is also intersecting with the set of playable cards. If you don't, if either there are no playable cards or you hit the draw button, then, okay, pick up a card. And then I'm going to ask you again, which card do you want to play? And then you either pick a card or not. Either way, I don't care. I'm going to say apply it. So notice that apply here. It doesn't matter if you pass this. Oh, it does. So I'll just put this. This can be card or it can be none. Type. Oh, I think it's just none. Okay. If not card, do nothing. Okay, so now it doesn't matter if we apply none. It will work, right? It'll just do no changes to the model. Okay, so here's active player play. Okay, so here's my hand. Here's the playable cards. So, okay, how do we get the playable cards then? Well, I want to do something like this. Okay, so I want to say collect all the cards for card in hand if card is playable. That's what I want to say. This is my wish list item. Do you agree that if I had a is playable method, if card has an is playable method, this would work? But I'm not well, okay, let's do it like this. What do I need to know if a card is playable or not? Well, a card knows what it is, right? So this card has all the information about itself. But I think there's one extra piece of information that we need in order to determine if a card is playable or not. Yeah, the card on the top of the discard pile. I'll give you credit up there as well, as I'm sure that's what you were going to say. Okay, so we need to give this self dot showing, I think is what we called it. Or maybe I have a method. Okay, I have a method, self dot showing. Okay, so I'm saying I have a card class, and I'm telling that card, I'm saying, can you tell me if you're playable, provided this is the thing showing on the table? So let's go back up to card. Let's go down to showing, and let's write a function is playable, given self, given this card, which is a card. I know why it's complaining, and this is going to be a bool. From future import annotations is what it's going to tell me to do. Oh no. From future import annotations, that should solve it. Nope. Give me 1 second. Oh, so I'll also post this all to the Blackboard right after class, so you can take a look at it. It has to be at the top, yeah. This is just a special thing, so I can where am I? You see, I'm using card here as a type hint inside of card. Somehow doesn't like that yet. They're gonna add it soon, but we could say self instead. I think that's a Python 11 thing. But anyways, so I'm in card. Card has a method is playable, and it's given. I'll actually just say that's what's showing. Okay, so true only when self is playable given that showing is showing. Okay. What are the rules of UqNO? The basic one, right? So you can either match color or you can match number. So if it matches the color or if it matches the number, it's playable. Okay, so let's do that one. If self dot, do I have a way of getting the color out of these things? No, okay, so I need to write a getter. Def get color. Whoops, that should be a string. And this should return self dot color. Cool. And I think we also need to get the value, get value. The value is also a string, return self dot value, okay? So again, wish list coding, like top down. I'm programming things and I'm like, oh, this is what I would like to have now, and I'll just sort it out later. Okay, so if self dot color, if self dot get color is equal to showing dot get color, return true, I can play it. If self dot get value is the same thing as showing dot get value, then we're good, return true. Okay, in what other conditions am I allowed to play a card? Well, showing is always going to have at least a color. The first card that's played is okay, so when I deal out all the cards to all the players, there's the draw pile, and I flip one card from the draw pile onto the table. And if that card is special, I keep going. Right? You draw until there's a normal card on the table. But let me pull up this picture again. So I've sorted all cases where I'm saying the color matches or the symbol matches. But what is not accounted for in those two matches? Yeah, any of the wild category. But this is a little bit more complicated now because I'm only allowed to play my special card if I'm not able to play anything else. So do we have enough information? No. What other thing do I need here? Your hand. Okay, so we'll correct this. So we have to be, because this is not how I implemented it in mine. We have to be a little bit clever about this. But you need to know your hands to know what is playable. This is like sort of a circular type of logic. So I'm pondering if I should pass the hand here as well. Or maybe we can agree that how do you want to solve this? Because in the way that I did it is I put is playable in the model rather than the card. I think that's one of the design decisions I had to pull back. I'd prefer for it to be here, but I don't think we can actually put it here without giving it more. Okay, no, let's just do it. Okay, so we have showing. And let's also get the whole hand, which is a list of card. I'm sure we can work out this logic. Okay, so I give it a hand and I give it the card that's showing. And I want to know if this card is playable, which means that it can't be in the hand. We have to be very careful about how we do. Okay, I'm taking this out of card. I don't think it belongs here. It's getting too dangerous. Because now I want to do something like, when you hand me the hand, the card that I'm asking is playable is in that hand. So it's automatically going to be playable, right? Because it's identical mate is there. Now I want to say something like, oh, okay, just remove it from the hand. But we're passing around aliases. So if I remove it from the hand, that it's going to destroy it. So, okay, I'm going to move it. Right. But this, like this, I am deliberately programming this with like making errors just so you can see like what my design process is like. Sometimes you have to be like, that seemed like a good idea, but on reflection, that was a bad idea. So the ability to delete something is important. Okay, so let's go back to model. Let's do it in model instead. I want to do something like, okay, let's create a method here, is playable. And what I'm going to do is give it a card. How come this is like, I feel this is hard now? I didn't remember this being hard before. Uh, you know what? I think I changed my mind again. I don't want to ignore this. It's the special cards which are really screwing with us here. Yeah. I don't want to mutate stuff. Like the answer to your question is, yeah, I can do it that way, but I want to be really careful with like where we're encapsulating code so I can repeat it. Well, what I want to do is have this is playable and like ignore wildcards for the moment. Just assume they're not playable. And then if I go is playable over my hand, if none of them are playable, then I say, then you can utilize your special cards. Yeah. So this is sort of like, I want this to be is playable, but not wild, right? That playable, normal and playable. Maybe we can do that. Not special is playable. Okay, so I don't need this hand anymore. Okay, so if this is, okay, so I'll just say something like, if self, self dot is special. Do I not have an is special? If this is special, return false, right? Because I'm answering the question, is this card not special and playable? So if it is special, return false. So now I can go back to here. Yeah, the active player play. So this is what I'm trying to do. Okay, so look for what is playable card, for card in in hand, if card is playable. Oh, not, how come it's not giving me that? I'll take this. Okay, so here are all the cards that I have that are playable and not special. If not playable, then playable is all the special cards. So card for card in hand if card is special. Do we have an is special modifier here? Yeah, we do. Okay. So this makes sense. Okay, so I may not be elegant, but I have my hand, and then I filter it for cards that are not special and playable. And if there if that ends up being empty, then I say, okay, go ahead. You can play one of your special cards now. Then I ask the viewer to ask a human to select from their hand something that's playable. And if they don't, I have to repeat this whole process again. And then I have a hand and I ask it to be played. Yeah, and I ask it to be played after I do this. Okay, so I think this will work. Yes. Yes. Self dot is showing. Oh, self dot showing. Is that something I have? Or is it a method? Is showing a method? Oh yeah, showing is a method. Self dot showing. And then here I'll put self dot showing. Okay, syntax errors. Never knew them. Okay. So let's see if we can execute one iteration of our game loop now. We have an active player play. And yeah, that should go through all the process of asking us for a card and then playing it. Okay, so we have to now have this callback function. So this callback function has to be in the viewer. So let's go to the viewer. Where is my viewer? Here. And I need to design something in the viewer. I don't know, maybe called get card or choose card. That self, I'm going to be given a hand, which is a list of cards. And I'm going to get a list of playable cards. And I'm going to return a card. Right. So to select a card from hand that is also in playable. You may say, well, why pass hand if no one can select from it? It's because the player still gets to see their whole hand. It would sort of make I could say choose from only these cards, but I think this is more in line with the real world model. Okay, so how do we choose a card? So I want to do something like while true. Okay. Input from the user. Choose one from, and I'll just say hand. That's just going to spit it out. That will be the card. If card is in playable, then we're done. We can just return card. And if not, keep picking, right? You don't get to leave until you're done. I'll say if not card, right? If we've input nothing, I'm going to allow the user to hit enter and choose nothing, then we're just going to return none, right? Because I'm always going to give the human player an opportunity to choose nothing. If they don't have to play a card if they don't want to. Okay, so that will choose a card. So let's go down here. So we're going to render. And now I want to do model dot active player play. That was public. Active player play. And I need to give this a callback. So that would be the viewer dot get what did I call it? choose card. Okay. So let's see if this works. Okay, and then I'll render again after this. Oops. So we screwed something up, and by we, I mean me. Oh, yes. There is no is special like this. That is wrong. Right. Let's try again. Okay, cool. It seems to be working. At least we got to that input. Let me just add a space in our viewer. Let's try again. Okay, so what's showing? Blue. Blue reverse. So I can play blue cards or I can play reverse cards. So I'm gonna enter in nonsense, and it should give me another opportunity to enter. Okay. Now let's try putting in something correct, but that's not playable. I can't play a green 3 on a blue reverse. So it's still asking me for something. Let's see if I can play a blue card. Ah, why didn't that work? Can I pass? Okay, so something. Does someone know my mistake? Because that'd be great. Okay, let's just do a little bit of debugging. No one said it was going to be easy. If card is playable. Okay, I'm just going to print out playable too. Choose one from hand, also in playable. It's going to be a real long dialogue, but it'll give us the information that we need. Let's try again. Oh, okay, so that's the problem. Okay, so it's telling us at the moment that nothing is playable, so the bug is in playable. Yes. Okay, so let's see. So where should I be going? Run. Oh. So that's another bug. This is the first round. The card on the table isn't allowed to be a special card. Okay, so where can we fix this? Okay, what class is certainly going to be the thing that fixes this? Viewer, controller, or model? Model. Okay, let's take a look at our model. What's responsible in our model for setting up the game? The initializer. So let's look at the initializer. Is there any intervention that we can perform here to make sure that the first card on the discard pile isn't special? Look at line 173. I even have a note there for us that it's broken. Okay, so yeah, here. This is where I'm moving. So I just need to do something like, okay, so move one card to the discard. And while self.showing is special, or is it just special? While self.showing is special. Yes, miss? It does have that rule. Yeah, so we've all been playing UqNO wrong. Like, I'm sure of this, but that's why I bought the actual rules, and it says that this would have been a disaster for our game, right? Because I can't have a colorless card hit the table. That doesn't make sense. Like anything that hits the table has to have a color. So I would have just made this a rule anyways, but at least UqNO was sensible. Okay, so I draw a card. If it's special, I just do it again. And then I just repeat this for as long as it's special. So that should solve it. Yes, miss? No, is special inside card we don't use the method, but I'm outside of card, right? When you use an object, remember that you're limited to using that object's methods. So I'm in the model and I'm asking a question about the card. So I'm not allowed to access card's private variables, but card is allowed to access its own private variables if you want. Okay, so that one's fine here. Where was I model? Okay, so that should sort that problem. Okay, let's try again. It's still empty. Okay, that's certainly wrong now, right? But for at least we're sort of bug killing. Okay, so let's go look at our playable and see why that's not working. I have to start using this. Not special is playable. Okay. So I'm a card. I'm asking if I am playable, given that this is the card that is showing. So if I'm special, I'm going to return false. That's correct, yeah. If my color is matching, I'm going to return true. Oh, I have to do this. Just in case it doesn't pass all of those things. Okay, this is bizarre. So let's go to the model. Right. Okay, so this is where the problem is occurring. Card not special and is playable. Okay, we can just let's just go in and play. I don't want that. Okay, so let's just make a card. Oops. I can always make any card that I want. So that's a red 6. And let's ask if this is playable. Oh, not special is playable. And let's say that red 6 is also on the table. The identical, this should certainly be true. Okay. What about if I change this to 9? Okay. What if I change this to blue? False. That's correct, though. Okay. So that seems to be working. Let's just print playable here. Something must be wrong, obviously. Well, I think in that case we did. So showing is blue 6. Oh, that's okay. Now it's saying that that's fine. Okay, so green 7, blue 6 or blue 8. That should accept it. But why didn't it accept it? Okay, so something is wrong. Let's go to our callback, which is the viewer. Okay, here's my viewer. While true, ask for a card from playable. And if the card is in playable, return card. Okay, that seems too simple to not be working. So can any votes of confidence here that this seems to be working? Oh, this is returning a card. That's returning text. And I need to return a card. Aha. So what do I do? Okay, does everyone understand what I screwed up here? I'm returning card, but at this point, card is a string. No, it's not. No. Yeah, card is a string. Because I've asked it to be. Okay, so I need to actually return a card. So what should I do? Not a string. That we could do. Yeah, we could instantiate the card from the string. But I don't really want to do that. Right? I don't want to create a new card. I want it to be the card from the ones that are in the deck. Well, I'll just do something like this. If card is in playable, For I need card again. Okay, I'm gonna want to call it temporary card. Okay, I'm gonna use this notation that we're not supposed to use. Okay, you'll lose style marks for this, but in this case, I think it makes sense, right? I'm gonna get a string card, and then for card in hand, if the card string is equal to the string version of the card, right, then return the card. Okay. This will be easier once it's the viewer. Right? Once it's the TK interviewer. Okay, let's see if this fixes stuff. So this is picking up all the cards I'm allowed to play. B9. 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 I don't. Okay, so something is still not working, but that was a bug anyways. 5 minutes. Let's try to resolve this. Because once I resolve this, what you have is a model that can execute one turn. So all you have to do after that is put that into a loop, right? Next player play, 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 while there's not a winning condition. Right? So you'll see that the controller in my actual solution is very simple. This is the whole controller. Okay. While there's not a winner, like play, like do one move. And the only reason there's an if statement is here is because I have to say it's a human move or it's a computer move, right? Otherwise, it would be even more simple. Okay, but I really want to try and do this. Okay, so let's just see what is happening here. So we are still in model, active player play. So here's my hand, here's my playable cards, and I want to just choose one of them. You want me to print from the viewer? Print card. Okay, I'll do this. Print card. And then the card string, and we'll see if those match. Yeah, that does seem fishy, eh? Red 8. Oops. Oh my lord, that's the problem. Yes. Yes. So this is my fault. Like this, so I should have been much more careful about this. I shouldn't have used the variable card. It wasn't a card. It was the string representation of the card. So I think hopefully this will fix it so we can end the whole semester on a positive note. Y5. Yes, it worked. Okay. I'm not going to be able to do more than that, but the whole game I'm going to put on Blackboard. But the hardest thing for the model was the apply. That took me about a week of going back and forth and figuring out the right way of doing it. So from this point, it shouldn't be hard to take it the rest of the way, at least with the text viewer. Well, you raise your eyebrows, but I said we have, I can say to the model, execute one turn. And all I have to do is keep executing one turn over and over again until someone wins. Now, right now, we're playing with only human players, right? You also have to write a viewer, like get robot move, which returns a move however you want. In my code, it's just, I just return a random playable card, which is incredibly effective UqNO strategy, it turns out, because I can not often beat the computer. Okay, so this is like not bad practice for the exam, is like taking this and like bringing it the rest of the way and then comparing it with the full blown TK inter solution. I'm sorry we couldn't get to the TK inter stuff, but it's written. I wrote it. You asked for UqNO, you got UqNO. So I guess this is it for this course. Start preparing for the exam. I'm going to be around to support you. When is the exam? In like 4 weeks or something like that? Not 2 weeks. That seems way too close. 3 weeks. So the average between all of our guesses, that's okay. So it's like do a little bit of prep every night. So like I want you to download last year's exam from the library, put aside 2 hours and try to do it. Try to do it as if you were writing it, because this is going to give you a baseline of where you're at. And then do the rest of the questions. So remember, try to do them. Like if you can't answer the question, like stew on it for a day, right? That's going to be a lot more effective than asking the EdStem what the right answer is. Like if you're struggling and we're like, oh, it's C, and you're like, oh, okay, I guess it was C. It's better if you actually understand why these answers are answers. We don't offer solutions, but they are on UqAddict. We don't endorse them, but they're there. I'm also happy to verify any answers you put on the EdStem. But good luck to you in your exams and the rest of the courses. Please do a little bit of study, and thank you for the real good semester, everyone. This was I actually really enjoyed this semester. I usually hate them, but this one was okay. Okay, so see you all later. I hope to see some of you in Comp 3400 in future years. And again, good luck, and bye chat too. I'll put this up later. Thanks for being with me. I have UqNO cards if you didn't get one last week. Or if you want a better one.